His talk is on gaze and touch interaction on tablets.
Yeah, hello. So at the onset, I just want to say that I was sick, and so excuse me for the occasional coughing during the talk. I want to present our work on gaze and touch interaction on tablets. So this is a more explorative work on whether eye tracking actually makes sense on tablets as well. And it was conducted with my supervisor Hans Gellersen from Lancaster University. Okay. So I want to start with prior work at UIST from the recent years. For example, our gaze and touch work here, where multi-touch gestures were essentially redirected to the image that the user was looking at, and this allowed to reduce a bit of the physical movement here. Or our work last year, where we used context switching, so the user could write with a pen when they're looking close to where they are writing. But when they look at the menu, they could change the color, for example, or other things. And it's again allowed to reduce a bit of the physical movement needs. And these works all focused on large screens. And we wanted to look at how these concepts apply to tablet devices. And tablets are a bit different here because naturally, users grip tablets because they are mobile and you hold them. And studies observe different kinds of grips here. And one of the more common ones are those grips where you hold them with a non-dominant hand, and you can still use your thumb for supportive touch interaction. However, the thumb is kind of limited in reach because you can only reach as far as your finger goes with the thumb. And our goal was to look at how we can actually extend the thumb's reach to the whole screen by using eye tracking. So, so therefore we propose the gaze and touch interaction on tablets. And in a sense, what happens is when you have a target here, like the red circle on the slide, you just look at the target, and then you perform a touch with your thumb with the holding hand. And this had two distinct benefits here. First of all, you can use the same hand for holding the device and interacting with the tablet. And as well, you can interact with the whole display because you can just simply look at any of the positions. And we wanted to explore this principle across three different applications. First of all, a home screen, and then a gallery and a browser. So we first implement a mock-up home screen here. And this is because home screens are on every tablet and they're kind of frequently used. So we thought, it would be quite nice. Okay, it's a bit jittery. Oh, no, okay. It would be quite nice to have some kind of shortcut interaction here. And what happens here in this video, I don't know why the video is jittery right now, but the point is that you simply look at the icon on the home screen and you touch with your thumb from remote. And this works especially well with eye tracking because the app icons are quite large and placed in a grid, and therefore the potential eye tracking accuracy isn't really relevant. And we found this really quite useful, this example, so we studied it, and we had two questions in mind. First of all, can users actually adopt this technique? And second of all, we want to go a bit more detail in this and compare this to the baseline, to default multi-touch, where you usually use two hands to select any app on the home screen. And this was a study task, so we had an abstract home screen set up, and users just keep looking at the target and touch down. And we used a gaze target snapping mechanism here. It's jittery again. Which means that the closest target to the point that you're looking at is selected. Okay, so we had two different techniques that we compared. Our task was the home screen setup, and we had 7 blocks, 24 targets. We had 12 users, and it was about 20 minutes per user. Okay, so the results can be summarized in 3 points. First of all, gaze and touch interaction was quickly learned by the user, so they needed some instruction to understand how this works. but after just 1, 2, or 3 trials, it was kind of obvious, and users conducted the whole study. And second, we found that gaze and touch interaction is actually slower than direct touch, because with the gaze technique, users usually waited to finish with the task. So users were looking at the target and tapped and waited until the visual feedback finished. While with direct touch, this was not really required, because you can just find the target once and then move your hand towards it and already look away to focus on the next task. However, we found that the gaze and touch interaction is actually preferred by users, and our Likert scale rating clearly showed that the gaze and touch interaction allows for much less physical effort. And our ranking showed that most users preferred the gaze and touch interaction technique. So overall, we found that gaze and touch is slightly slower, but was found more comfortable by users. And this was kind of a promising result, and we want to explore more sophisticated applications, such as a gallery application. So in the home screen task, we just looked at the simple selection of gaze and touch, and we then focused on like implementing a whole application for a gallery where we can actually select objects like images, look at them in detail, and also go back to the gallery and perform scrolling and all the other things. And the question was, how can we actually integrate gaze and touch within this concept of different interaction techniques? And for this, I want to give it a demo on the gallery application. I've set up the Surface Pro 4 here with an eye tracker. Okay. So this is the application, and as you see, the red circle shows where I'm looking at the moment, and the orange circle shows where I'm touching, and obviously I'm holding the device on the left side, so my touch is kind of in this area. And what I can do is I can look at the either the image gallery or the folders on the left side. And with this, I can kind of change the scrolling direction. So when I perform a scrolling gesture here on this side, but I'm actually looking at the image gallery is scrolled because that's where my visual attention lies on. And if I... oops. Okay, crashed. Oops. Had to happen. Okay, so this is just about scrolling, but the main benefit is actually that you can so either use normal direct touch interaction. So let's say my dominant hand is used here to select an image here, and then I have it here, and I can go back on the top. But I can also do the same thing from remote. Let's say from this side, I'm scrolling the image, and then I'm looking at a specific image like this castle here, and then I tap and I open this image here, and I can just simply look at the back button and tap again to go back, and this allows for a really seamless use of scrolling here, the whole image gallery, and at the same time selecting images and looking at them. And in this view, a dragging operation actually changes between the previous and next image here. And when I look at the quick list at the bottom, I can actually quickly scroll through the next images, or just get back to the single switching here. So these are some interesting things that we've found for the image gallery that allows users to actually use thumb-only input to quickly browse the image gallery application. So, okay. So, I don't need to show the videos. The previous two applications, the home screen and the gallery, were kind of based on objects. So they always had a specific set of objects on the screen, and the user interface was based on a grid. And all of the targets were kind of big, so which made it really easy to use eye tracking selection on this, because eye tracking can be a bit inaccurate and so on. Sorry. However, we also wanted to support more precise interactions. such as in a browser, where the browser is more inspired by, or more designed for the WIMP paradigm, I guess, because when you use a cursor, you're actually more precise, and it's kind of more comfortable to interact with it than when using multi-touch, because of the amount of small hyperlinks, text, and so on. So we want to implement a browser that supports cursor interactions. However, we encountered a problem here, which is the page scrolling and cursor dragging problem. So on the left side, you see that when I use my thumb, I can actually scroll the website. On the right side, you see that when I use my thumb, I move a cursor around. And both of these tasks are quite natural for the thumb. So what you see on the left side, the page scrolling one, is the one that we're really used to from direct touch interaction. And what you see on the right side is cursor interaction that is also quite natural, because we are used to it from tablets, not from tablets, but from laptops, from touchpad interactions. So to solve this, we developed the CursorShift technique. And this technique essentially uses a special tab to switch between direct touch and cursor interaction on a browser. And a direct tab means, and this special tab means either it's a direct tab or an indirect tab. A direct tab means you kind of look closely where you're touching, and an indirect tab means that you're looking quite far offset from your touch point, which is in our system about 7 centimeters. And it's kind of hard to explain, so I want to give a demo on this as well. So this is our custom browser that we developed, and what you can see is the red circle is where I'm looking at. I'm looking at the picture there, and looking at that one there, and the orange point is again showing where I'm touching. So the orange point is obviously kind of in this area, because that's where I'm gripping the tablet. And so I can normally scroll the web page at any time, as you can see here, independent of where I'm looking. And when I use my dominant hand to touch somewhere in the middle, like this, for example, on a link, I can select link like any usual tablet browser. However, if I tap from remote, such as in this position, a cursor appears at the position where I was looking at, and then I can move the cursor around. Hope you can see it, and then I can precisely position the cursors at the link that I want to select, and tap again to click it. So, and immediately after that, the system switches back to direct touch interaction, so I can continue scrolling on the website again, and I can just do this forever, and really comfortable, because all I do is I'm holding it in this really uncomfortable grip here on the tablet, and I'm using just simple thumb dragging and tapping actions to browse the whole website and click on a few links, or I can also click pictures here, or go on here to even select any of the buttons on the whole interface. Oops. So this is quite kind of this makes the browsing experience really easy with one hand on the tablet, and one of the benefits as well is that you can. So when you use multi-touch on a browser, some targets are really small, and then it gets really difficult to actually select these targets. But even when you use the CursorShift technique, you can actually quickly switch to the cursor at any time and select even very small targets, as you can see in this example. Okay, so we extended the browser with an additional menu area. So we had this kind of split screen here where the main web page was used for CursorShift interaction, but the menu had a slightly different interaction technique that I also want to show in a demo. So activate. So, sorry. So when I look at one of the tabs, so the tabs are quite large targets, so it's kind of unnecessary to use a cursor. So we thought we can just look at the tabs and use a single tab gesture to to select them, such as what you see here. And this allows to really quickly change between the tabs on the browser. And when you actually hold your thumb instead of tapping, you get this little line that indicates, okay, now you're in control of it, and then you can change between the different tabs in case of smaller targets. For example, you can go to the, okay, first go to this one. For example, if you want to go back, the targets are a bit smaller, so you need this. You need to drag a bit to select precisely the right button. But then it's quite easy to use this this technique to navigate the browser websites. So, for example, now I'm going back to the starting page, and this interaction is a little bit like a marking menu. So, when you hold your finger, you can go left and right to change between the interface elements. But when you go up, you can close a tab. As you see here, the visual feedback shows that the tab goes up here. And if you go down, you can go to the address bar, which indicates that you can, when you touch up now, you can actually open the virtual keyboard, and then you can type something in to search it. And even the keyboard has some case interactive elements in there that you can use, but this is just a gimmick, right? I want to show that. So when you're using your thumb only, you can look at one of the keys and just type in something like this. But this is also complementary to normal direct touch input, so you can just simply use your dominant hand then to type anything. Then. Okay, so there was the demo. Oops. So again, the browser menu has this marking menu type of functionality in there. And okay, so in summary, what we did is we explored different kinds of interactions on 3 applications. So on the home screen, we showed that a simple selection can actually lead to less physical effort for the user. And with the gallery and browser application, we showed that we can also support more sophisticated applications and a lot of different tasks that users can actually use with thumb-only interaction. And I want to conclude the talk with 3 points. First of all, what I've just said, that gaze and touch interaction can be really useful to enable single grip, single touch, and single hand interaction on a tablet. And at the same time, you can reach the whole user interface. And second, the resultant interaction techniques, they're not meant to be a replacement or something, but rather they are used complementary to direct touch input, because when you use the dominant hand, you can still use normal direct touch interaction. And at last, we also developed the CursorShift technique, which is essentially a switch between direct touch interaction and cursor control. And we wondered whether we can extend this actually to other WIMP applications. Okay, thank you very much. Now happy to answer any questions.
Questions?
Hello, I have a question about you have a user study to compare the direct touch and using the gaze touch for selection some buttons. And I'm curious about, have you ever compared about some technique like a bezel swipe in Kai 2009, they solved the problem for how to reach, and they only use the touch to also can select the target is hard to reach, but it's applied on the smartphone, but maybe it's also can apply on a tablet, and maybe can compare with the gaze and touch. Yeah.
So I think the question was whether there are any
Yeah,
touch.
I'm curious about what's the performance maybe compared with the gaze and touch and other solution to use the touch
to reach remote targets.
Reach the how to reach target.
So there are a few techniques for that that use actually only touch to also interact with the whole screen. And one very simple one is using a cursor, like on a touchpad, I guess. But these always have the issue that you need to kind of switch between either using normal touch or that, and it's for that you need to allocate some kind of screen space to have some kind of indirect control, maybe a widget or something. So in our design we didn't want to have some kind of splitting of screens. We just wanted to enable both input modes.
Okay,
yeah.
thank you.
But,
Hi, I'm Julia Schwartz from Microsoft. This is really great. I'm curious if you had to recommend one technique that works best under noisy eye gaze input, because your demos work really well. I guess you're very good at gaze input, but one of the things I've seen is for some people it works really poorly. So which of your techniques actually work well even for noisy input?
So, yeah, I guess I have to say it depends. On the gallery application, there were like large images and so on, so you could just look at them, and it was quite easy to distinguish that the user was looking at the image. But of course, if the gaze inaccuracy is a bigger factor, and you possibly have smaller targets, like in the browser, then it might be more useful to use to instance a cursor or something at the user's where you're looking at, so that you can refine the position and have a more precise input. Yeah.
Could you clarify how you switch between direct input and gaze-based?
So I used this mechanism from my prior work last year. So in a sense, when I'm kind of touching in this area where I'm looking, then it's like processed as direct touch input. But when I'm touching clearly far away from it, I mean not very far away or something, it's still on a tablet, but then it's kind of this indirect interaction.
One more quick question. Okay, I have one. Is it possible for users to use all your interaction techniques together?
Yes.
Okay, then
No,
I'm curious on the learning curve of that.
Yeah, it's this one. So, learning curve. Obviously, you have to learn it because it's like not really intuitive on the tablet, because you kind of assume direct manipulation. But I don't know. I have to study it.
Okay.
Yeah, thanks.
Thank you, Ken. Let's thank Ken.